we've seen that the same variable can only be bound to one value. But in fact, this is not true for identifiers. The same identifier can refer to different values at different points of the execution. So for example, if I do declare x equal 42, browse x, if I execute this, feed region, I get 42. Now if I do declare x is 11, browse x, and I do another feed region, I get 11. So the same identifier x at one point refers to 42, the other point refers to 11. So how is this possible? In fact, there's no conflict with single assignment because at the 2 points in time, the identifier will refer to different variables. So the environment is different. And in fact, the second declare instruction, we say it redeclares the identifier. And the declare instruction gives the identification between the identifier and the variable that's valid until the end of the session or until there's a redeclaration. There's also another instruction, which is a variation on this, called local, which makes the redeclaration only valid in a particular area of the program. So for example, if I do local x in x999, and then I do browse x end, so the local goes up to the end and no further. And beyond that point, the x refers to what it referred to before. So if I do feed region here, I get 999. But if I do browse x here, what do I get? Well, I get whatever the x was referred to before, which is 11. So in fact, with redeclaration, one can cause an identifier to refer to a different variable at a different point in time. And there's two instructions here that do redeclaration. The declare instruction, which is an interactive instruction going to the end of the session, and the local instruction, which can also be used inside of programs, but which limits the redeclaration to a fixed piece of the program. So from the local to the end. So with this, we can define what's called the scope of an identifier, or more precisely, the scope of an identifier occurrence is that part of the program text in which that same identifier refers to the same variable or refers to the same original declaration. And the notion of scope is very important to understand the execution of programs. So we see that an identifier can be redeclared. We have here the first declaration, which declares identifier x to refer to variable little x through environment E1, and then we redeclare with a second declaration, so the same identifier x refers to the variable little y through another environment E2. So what happens is the same identifier refers to a different value. But there is no conflict with single assignment. The values of the variables do not change because each occurrence of x corresponds to a different variable. The interactive environment, of which the declare is an instruction, will always keep the same correspondence until the identifier is redeclared, if ever. So in this example, after these two declarations, x will refer to 11. Okay, there's another instruction called local, which is similar to declare, except that the redeclaration finishes when it reaches the end. So it's only a fixed part of the program text. So for example, in this instruction here, I have local x in. X is 42, until the end. And after that, the x will no longer refer to this variable that was declared here, but whatever it referred to before, if anything. So this lets us introduce a fourth concept. In addition to identifiers, variables, and environments, the fourth concept is called the scope. The scope of an occurrence of an identifier is that part of the program text for which the occurrence corresponds to the same variable declaration. So for example, the scope of this x here is in fact the part of the program that starts from the local ends here. Here we have another local, but that's another declaration. So the scope ends here, there's a hole in it, and it continues here. So the scope of this occurrence of x is two separate parts taken together, this part and this part. Okay? The scope of an identifier occurrence can be determined by inspecting the program text. We do not need to execute. So this is called lexical scoping or static scoping. Okay, so in this example, the first browse will display 42, and the second browse will display 11. And the third browse will display, of course, 42 again. And there is no conflict between x equal 42 and x equal 11, even though variables are single assignment, so you can understand why. I will let you answer that question.